Good morning, Ray. How are you doing?
Good morning, Lucy. All good, thank you.
Brilliant. So I'll let you go and do your thing.
Thank you very much. Had a message on the chat that someone's got audio issues, but everybody okay at the minute? Everyone okay audio-wise? Yeah, we've got an okay. Great.
Yep. Okay, brilliant.
Thanks for that. Well, yes, good morning, everyone. My name is Ray Arrell from Regen, and it's great to be back here at the Energy Storage Summit this year. An event I've been involved in as a punter and a speaker in previous years. So yeah, it's great to be invited back today. For those who don't know much about Regen, Regen is a not-for-profit mission-led organization, Centre of Energy Expertise based in Devon. We have a mission to transform the world's energy systems for a zero carbon future. We're a company that have sort of four main strands. We do analysis and insight work for specific clients, as Regen acting as a consultancy essentially. We're a membership organization. We have a wide range of organizations that are members of us and also of the electricity storage network that Regen actually have been managing for just over 2 years now. We're an events organization as well. We run a number of events from technical workshops all the way through to our conference that we run normally in the Bath Assembly Rooms around next month. Unfortunately not this year, but hopefully we'll be back to that soon. And we have a lot of work that we do around policy, advocacy and lobbying around specific issues in the energy sector. I mentioned the electricity storage network, the UK's only industry organisation dedicated to electricity storage. We took over the management of that a couple of years ago. You can see some of the members that we have of that network, and the sort of three working groups that we particularly focus on as part of the work that we do with the ESN, focusing on markets and revenue opportunities and barriers, sustainability, safety and supply chain, and we also now have a strategic liaison meeting, a regular one with the electricity system operator. So I'll be drawing on some of the work that we have been doing with the ESN for today's presentation, as well as the main themes. So on to today. It was about 3 years ago, actually, that we looked to produce and do the final stages of our second energy storage paper as a company, Energy Storage, the Next Wave. We'd essentially like to revisit this paper and see what's happened since 2017, some deployment, some of the barriers and enablers that we identified at the time, what's happened around those areas, and generally touch on some of the topics that we discussed at the time. So the paper was essentially a mixture of a state of the sector for storage, as well as I'd specifically focusing on the business models and potential opportunities for energy co-location, hence why we're revisiting this today as part of the session. The paper was launched, as I said, in late 2017. It was sponsored by Greenhedge, Triodos and Vattenfall. And I was pleased to see Jake from Vattenfall actually on yesterday's session. And it was actually a follow-up to our first paper in 2016, when we were first looking at the potential for storage in the UK, which is towards a commercial model. In these papers, we essentially likened the storage sector to an unsolved Rubik's Cube, where many of the factors enabling storage to progress, whether it's technology, sources of income and revenue, financing, policy and regulation, were all starting to emerge and see some progress, but potentially they weren't all lined up. We then built on this analogy in the 2017 paper, The Next Wave, where we actually identified policy and regulation and access and viability in the markets as potentially the hands of the driving the cube, with the rest of the sectors of technology, timescales, costs and revenues would snap into place with those two core things. In the paper, we also identified a number of specific classes of asset or business models for energy storage. So we wanted to divide them down into a number of different classes of asset. And you can see them here, a mixture of sort of the standalone type models, which is the response services, the reserve services, or the energy trader type models, to co-location, where we have co-location with generation, whether it's renewable energy or potentially fossil fuel generation, as we're starting to see, or co-location with high energy users to support on-site services, energy management on-site, and potentially avoiding high cost and network charges. And then obviously the smaller scale business model for deploying storage, which is domestic and community scale. I'd like to move on to deployment. So in terms of setting the scene, that's how we defined storage and looked at the sector. But we actually wanted to see, what's been connected since. So what I've shown here, if we firstly look at the transmission network, you can see access to the transmission entry capacity register, or the TEC register. We've got a couple of snapshots of literally when we launched the paper, November 2017, and a refreshed view of connection interest and activity this month, 3 years later. So what are we seeing? So other than the obvious sort of legacy storage projects, the pumped hydro that remains connected and operational, the battery storage pipeline was pretty small at the time, unsurprisingly, connecting to the transmission network. We had, sort of 50 odd, 60 odd megawatts potentially in either under construction or with an approval or in scoping, but none actually directly connecting to the transmission network at the time. And if we move forward to today, we have a significant pipeline potentially looking to connect to the transmission network, with just under 4 gigawatts of new battery projects in scoping or in development, and a little bit of a small drop-off of potential new pumped hydro projects as well. But still, based on the data that we see in the TEC register, other than the 250 megawatts that the National Grid ET identify as embedded capacity, we still have no direct batteries operating on the transmission direct connection network. If we move on to the distribution network, a very interesting story we could see. So this is firstly, data access or access to connection data on the distribution network has evolved and improved significantly since we launched the paper. In late 2017, we had information from embedded connection registers or connected or contracted generation registers that DNOs published at the time. And we were able to look at sort of 9 of the 14 license areas. And we had only 5 projects totaling 28 megawatts connected and operational, but a significant pipeline of 100 odd sites with just over 2 gigawatts looking to connect, and a potential further 3 to 4 gigawatts of inquiries that we had sight of at the time. Zoom forward to today, where all the DNOs look to publish their embedded capacity registers, which were previously known as the system-wide resource registers. We have a much better view of connection activity across the networks. So this is a bit of a summary of those registers, plus a bit of our own analysis because of the work that we do supporting some of the DNOs with their distribution future energy scenarios work. We have a lot of time to scrutinize connection pipelines, but you can see here a summary where we now have over 770 megawatts of storage connected and operating on the distribution network, a significant pipeline of just under 6 gigawatts with accepted connection offers. So not even inquiries, that's actual live potential connection exchanges. And there is likely even more inquiries that are coming in to the DNOs to connect storage. So a significant development of capacity connected and also in the near-term pipeline. But it'll be interesting to see in the next few years how many of those sites that with connection offers will go through to connect. So if we bundle that together and look to see what the future could hold in terms of moving that projection forward. So you can see the historic deployment. This does also include pumped hydro, I would like to say, It's not just batteries. I'd like to see the whole sort of storage picture across the system. You can see that if we were to include the initial pipeline where we have either accepted connections or going through to development, we're up to almost 8 gigawatts. And if we incorporate all the projects that are also in scoping, we're up to almost 11 gigawatts. And it's interesting to compare. In the next wave paper, we had a high growth scenario of potentially 12 gigawatts of connected capacity by 2030. I should say that's power capacity. The energy storage megawatt hour capacity is a separate measurement that we don't have as strong a view in terms of published data. So this is focused predominantly on power capacity. But there's a potential interesting disparity there around above about 1 gigawatt, but obviously we still have 10 years to go to our 2030 high growth scenario. So how much of that scoping and pipeline will connect, how much more will come into the inquiries, and how close might we get to our 2030 aspirational target that we looked at the time. If we look now onto the specific topic of co-location, which is around the topic of today, in the paper we explored a number of use cases for co-location, both for co-location with generation, but also co-location with high energy users. And these are some of the use cases and benefits that we identified, whether it's time shifting generation, away from peak periods to higher price periods, or if you're co-located with demand, to when consumption is higher on site. The potential for mitigating constraints with generation was a potential area we looked at. Peak network charge avoidance. Interesting to see the developments on network charging reform under the target charging review and the significant code review, how much storage will actually be able to support high energy users to avoid the resultant charging structures that we will see come to the fore. Will be interesting to see. So will that actually still be as significant an opportunity for storage behind the meter? Obviously, network services as an additional source of incomes for co-location was definitely something we considered, whether that's frequency response or the new dynamic containment version of that we're hoping to see, or reactive power or power quality services that storage could provide, both outward and also potentially inward to the site. And also we looked at price arbitrage, the potential for optimizing price sales for generation projects, and for behind the meter we looked at the potential for storage to actually act to maintain supply if there are blips or actually disconnections or interruptions to key and critical sites. And there are some industries that are potentially seeing the sort of UPS type functionality of storage as a potential benefit to avoid lost process uptime and similar. So if we move on, to looking at what's happened with co-location. So a view would be from what is in planning. So the Renewable Energy Planning Database classifies storage projects that are co-located or standalone. So if we were to look at a snapshot of that over the past 5 years, obviously this is up until June 2020, so year to date for 2020. But obviously the historic deployment has been heavily weighted towards standalone, as you can obviously see there. But we also had around 25% as a mixture of co-location with fossil fuel generation and with renewables. If we look at the 5 gigawatts that have planning and are awaiting construction as of June this year, that trend pretty much continues to be the same. But if we were to look at additional 600 megawatts of projects that have actually submitted planning applications, the trend actually shifts drastically towards co-location with renewables being one of the or the dominant potential business model. So that's a really interesting shift that we can see in planning, and it'd be obviously interested to see whether those projects are truly co-locating and cooperating with the generation projects, or whether they are purely co-locating geographically and sharing a connection point, but actually operating as a standalone business asset, or whether they are providing direct operational benefits to the generation projects that they're co-located with. And that level of detail is obviously not going to be seen in the REPD, but it would be interesting to see what type of co-location those projects end up being when they come through to operation. So I'm going to move on to some of the challenges that we highlighted in the Next Wave paper a few years ago. So this was sort of a summary of the conclusion that we touched on. These aren't exhaustive in terms of the barriers and challenges that we talked about, but for storage to fully realize its potential, we thought, first off, there is a need to enable more participants to access the balancing mechanism as a potential source of flexibility operation for storage to really go for, and the financial benefits that come with it. We felt that the system operator should deliver on their aspirational plans to rationalize and simplify national balancing services and flexibility markets. And also at the time, 2017, local flexibility was a fairly new thing. It was very new, in fact. And we felt that these markets must develop to enable storage projects to access, and because we felt that storage could well be a really good provider to meet the type of services that the DNOs or DSOs were procuring at the time. So if we were to take those in turn, so first off, the challenges on the storage sector around the balancing mechanism, it's fair to say that a lot has happened since then. So whether it's the first time, this is a handful of headlines, first time that the storage asset entered the balancing mechanism via a virtual power plant in 2018, the potential for the first trade as a virtual lead party earlier this year, and then we've got another 100 megawatt hours entering the balancing mechanism in September, to even late last week where Tesla announces the first potential to access the balancing mechanism through API interfaces. So lots of development in terms of accessing the balancing mechanism and opening up and widening the access to the BM. And there's some information from Cornwall Insight there earlier or late last week, in fact, where you can see that there's about 149% increase of the bids and offers coming from battery storage in the BM. So I guess a question remains, will storage displace even more CCGT and even other gas reciprocating engines in the balancing mechanism as we move towards net zero flexibility sources? If we move on to the ESO's national balancing rationalization, again, progress has been seen here with the response and reserve roadmap and the development of dynamic containment as a new frequency response service. A lot of progress has been made here in terms of rationalizing and simplifying some of the services that we see, but I guess more progress can always be made in terms of simplifying and standardizing the way that different technologies access and utilize and provide services to the ESO. On the DNO side, on local flexibility, it's really interesting to see how these markets have developed in each license area. First off, there's a lot more activity in terms of auction rounds from all the DNOs. You can see some snapshots here of the constraint management zones that are currently out to tender or identifying the potential for needs for services from the DNO, whether it's from Piccolo Flex online trading or the Western Power flexible power platform. And if we were to look based on Piccolo's published data, some of the technologies that are active in these auctions, in these local flex auctions, you can see that storage is actually one of the stronger. That does include EV, I believe, as well, but battery technology essentially is one of the stronger participants to provide presence or activity in the auctions that we're seeing, which is very encouraging to see. And there's also been a lot of progress to start to standardize how the local flexibility markets are offered and contracted, and the requirements and entry requirements across the different DNOs through the Open Networks project. You can see there's a number of outputs from that work stream around flexibility services to try and make sure that someone in one license area to another has a standard experience, essentially, for how they look to go through to enter and procure flexibility into these markets. Obviously, I can imagine there's more work to do here, but it's interesting to see on the table on the right there, in terms of projections for capacity being procured, there's a lot more local flex tenders to come in the coming years, and I can imagine that storage will continue to be a dominant or strong presence in these auctions. So a potential question remains, these services are predominantly around managing demand peaks and network resilience, but will we start to see network reforms or further reforms to see local flexibility to start to address generation constraints in the future as well as demand? I wanted to briefly touch, mindful of time, but I wanted to briefly touch on some of the other developments that the ESN has been working on, building on some of these challenges that we highlighted. So the ESN's definition of storage has been adopted into the generation license. So we've managed to work with industry and BEIS to successfully remove the threshold on planning for storage, where it will now be considered at a local level, which is really good progress to see. Dynamic containment as a new and better product for frequency response. It's great to see that having a soft start next month. And also we've been strongly advocating the measurement of carbon in flexibility markets to the ESO and BEIS. And we're really pleased to see that that will now hopefully be a key focus on flexibility in the latest edition or update to the Smart Systems and Flex Plan. For Regen and the ESN, that's a really great thing, and hopefully will be followed through. I'll finish really on a couple of slides where our sequel to the Next Wave paper, predominantly authored by my colleague Madeline Greenhalgh, who also works on the ESN, Electricity Storage Pathways to a Net Zero Future. We highlighted a number of, there are still barriers that we need to overcome around business rates, the potential that storage is not defined formally, legally, in the electricity license framework. Its targets for storage are still potentially lacking. We obviously have a lot of scenarios, whether that's from the National Grid's future energy scenarios or from Imperial and the CCC's publications, but there is no clear government target or pathway into how much storage we will need, where it will be needed, and when. So that's definitely an existing continuing barrier. Accessibility to markets is something we've covered a lot, but there's still progress to be made. Supply chain, the challenges faced in the supply chain from sourcing raw materials all the way through to recycling is definitely something that we think awareness needs to be increased in the challenges faced by the supply chain. And long duration storage, there's also potentially no clear plan for what we need for long duration storage, how we can develop it. Obviously, we welcome things such as the storage at scale competition, but we think that we need to really put a line in the sand and a milestone for when we need long duration, how much we will need, and what it will need to do. And therefore, the technology development should follow. I'd like to finish actually with highlighting some of the recommendations on how to address some of these barriers. And I'd actually like to hear from you guys in terms of what you think, if we were to highlight these 6 key areas from the paper, from Madeline's paper that we launched through the ESN. Which do you think, or which area do you think is the most challenging? or the most important challenge that we should look to address? And the answer is obviously potentially yes, all of them. But we would like to know, if you were to pick one of these six, would it be to include include and define storage in the electricity generation or electricity license framework separately? Is it to get a clear signal or target from the government for electricity storage over the next decade? Is it to develop an industry plan for long duration storage? Is it to increase awareness of the challenges that the storage supply chain faces? Or is it to eliminate further market barriers that are in place for storage to reach its full potential? Or is it around business rates relief for storage at all scales? So hopefully, if Lucy could launch that poll, it'd be great to see or hear any views from you guys. And I think I'll leave it there. Many thanks for your time, and it's great to be involved. And I'm happy to take any questions if we've got time.
Hi, Ray. Thanks so much for your presentation. I have launched the poll. We've got quite a few votes coming in already. I'll just leave it up there, I think, for a few more minutes. Because at the moment, well, there is one clear winner at the moment, but we'll just see if that changes. Can you see the poll yourself?
Yeah. I'm just flipped onto it actually. Yeah. So we've got eliminating market barriers and valuing carbon, which is really good. That's one of the key areas that we will definitely be lobbying on, or continuing to lobby on.
Yeah, so I'll leave that up there, and then I'll publish the results for the benefit of the audience. And I will move swiftly to questions just because we're running out of time, unfortunately. But yeah, thank you so much. I think that was really, really interesting. And it's obviously great to see that, you know, there's been significant growth in the storage market. So I'll take a question from John Bennett. So John's saying, our authority purchases via pass-through contracts. 30% of our energy charges black rates on our UMS for street lighting. Is there a business case and mechanism for using storage with the DNO to use storage as a demand offset?
I guess it comes down to the types of services that the DNO are procuring. So predominantly the services that DNOs are currently going out to tender for, from my awareness, is to support evening demand peaks in the winter, although that could stretch to other times in the year, to help with planned maintenance downtime in certain areas or substation zones on the network, and to support unplanned interruptions to the network, whether that's from overloads, weather events, unplanned outage events that they experience on certain parts of the network. So those are the types of services that they're procuring for at the minute. So specifically, I guess it's where you're located is actually a very important factor. So whether the assets are in one of the CMZs that the DNOs are procuring for, and also whether the operability of those assets meets the time frame or the window in terms of month, day, and even clock time that they are procuring services for. So I would encourage you to go to your DNO, specifically go to their website, possibly put flexibility services in, and you can see what their current live procurement is, and see whether it aligns with what your assets can provide. Great.
I hope we've got quite a few questions coming in, so
I'm sorry we run over a bit.
That's fine. We can extend it slightly. So John, I hope that answered your question. We'll just go through some of the others. So we've got another one regarding whether are you optimistic that standalone is commercial, and why or why not? And also, second part of that question, what has triggered the recent growth in co-located storage planning applications?
Okay, two separate questions. Let's tackle them one at a time. I guess standalone is definitely a model that will continue to see deployment. I think the system will need more flexibility as we go into the future, from all sources it can possibly get hold of, I suppose, as I would say. If you were to look at the National Grid Future Energy Scenarios study that was released for this year, FES 2020, the amount of flexibility needed on the system related to the growth of electric vehicles the growth of electrified heating, and also of general population growth, etc., and the increase of renewable energy in the grid fuel mix as we go out to 2050. I reckon standalone storage will still be part of that mix. It's tricky. It's a hard model to make stack up with competition for existing flex auctions. Volatility in the market should be an ally and a friend of storage projects, but it also needs a lot of very challenging control philosophies to be able to maximize the benefits of that. So I guess the fact that we have storage projects that are operating now answers the fact that yes, it is a commercial model, but it is a challenging one, and there will be a point where competition will probably have some projects that come on top over others. The second point, what's triggered the recent growth in co-location? An interesting question. I don't fully know the answer. I guess the potential model of subsidy-free solar and the growth that we're seeing, the pipeline that we're seeing in solar. Regen published an infographic around the sort of shovel-ready capacity of solar that we're seeing in the UK. I can't remember the specific figure, but it is in the gigawatts. And so potentially post-subsidy is storage the potential to enable those solar projects and those wind projects from maximizing their business case. So it could be that new builds are looking to co-locate these technologies as one project from the outset, and there may also be some companies that are looking to retrofit storage with their existing generation assets to see if they can maximize or increase the revenue that they're getting from their existing assets.
Brilliant, thanks, Ray. I think that's a very good answer to that double-sided question. So we've got one from Ines. He says, thank you for the excellent presentation. And what types of storage were you covering in your study? I think you said mainly batteries and pumped hydro.
Well, yeah, I mean, in terms of the data that we have access to for deployment that I showed, it is predominantly batteries and the existing pumped hydros. However, we looked at all types of technologies. We looked at compressed air, liquid air, we looked at ultracapacitors, we looked at power to gas, whether it's hydrogen electrolyzers, etc. So we did actually do a high level assessment of the sort of state of play of all the key technologies, and I may have not included all of them. I mean, there's gravitational storage, there's ammonia, there's a number of technology variants, and even battery chemistries we could talk about. But yeah, I think the paper and the latest paper that we launched earlier this year does look at more than just batteries and hydro. But in terms of the deployment that we're seeing right now, 99% of what we're seeing connected is pumped hydro legacy or battery storage that we're seeing connect now. But we are interested in all technologies. Great.
And final question from Robert. So are there any open frameworks currently available for interacting with the BM?
Well, the balancing mechanism is not something I am an expert in, but there's definitely been an increase in activity, and there is a sort of regulatory commitment to widening the access to the balancing mechanism. So those headlines that I showed, so virtual lead parties where specific aggregators or energy services companies can bid in portfolios or individual sites into the balancing mechanism instead of just the supplier-led balancing mechanism unit type approach. So the VLP is definitely one mechanism that can be using mechanism too many times there, but one method for accessing the balancing mechanism, and also the API method that the control room at National Grid can have access to a wider range of entrants. It definitely encourages you to read the developments that we've seen from Tesla accessing the balancing mechanism within the last fortnight, and the method by which that they're doing it would be interesting to follow up on.
Great, thanks for that, Ray. And so I think one in the absence of any other questions, just one final closing, I guess, remark or question from me. So we're seeing, obviously you mentioned the removal of the 50 megawatt threshold for large scale storage projects. If you had to take a punt on the growth between the residential and commercial market or the utility scale storage market in the next, say, 3 to 5 years, which do you think will have the highest growth, just in your opinion?
Interesting. I think that very much comes down to outcomes of reforms. I think if we were to pick the commercial industrial scale, for example, the potential and interest there is strong. However, the case of deploying a storage asset at commercial industrial premises with all of the reforms that we are seeing proposed to network charging around one of the peak costs that those users are looking to try and manage, storage may not be enabling them to manage or avoid those periods with the reforms that are being proposed in terms of potentially moving some of it to fixed standing charges rather than time of use based charges. So I don't know, whilst the interest is still there, I think there may be a period of holding off whilst we understand these reforms in the high energy user commercial industrial sector. So maybe not that in the medium term. The domestic sector, whilst there's potentially still a growth and an uptake of rooftop PV, the potential for storage to be deployed in homes is possibly tethered to, are you going to buy an EV? Because why would you have a battery and an EV if you can try and make use of vehicle to grid? Or actually, could that be an enabling factor for you to buy a separate battery because you can see the electricity is the way forward and you've got a connection capacity able to do it? Or actually you're going to electrify your heat and take your boiler out. So could having a battery storage buffer enable you to make best use of time of use tariffs and things like that? So I think the domestic sector could increase and see growth in the medium term significantly in areas where electrification does start to significantly take hold. But I think sort of grid scale projects, if we're just talking about pure megawatts or gigawatts in the ground, purely because of the size of individual assets, the average capacity size, I think larger scale assets will still continue to be most of the project capacity that we see connected in the medium term, with the other models starting to catch up.
Great, thank you so much, Ray. Really enjoyed that, and thank you for your contributions, and thanks to the audience for all their questions. So we hope to see you all back very soon.
Thanks very much. Great to be involved. All the best.
Thanks, Ray. Bye-bye.